Welcome back. This is another exciting episode of Mr. Takeda Teaches Algebra Fanfare. Boop, boop, boop. This is the Math 8 edition. I'm your host, Mr. Takeda, and I'm going to teach you some math, some algebra, really, right now. This is lesson 6.4 in comparing linear and non-linear functions. All right, we looked at linear functions yesterday when we get a line. That's what we get. What do we call them? Linear functions. For nonlinear functions, I guess we're going to get something other than a line. Let's take a look. Let's go. Okay, so the graph of a linear function does not show a constant rate of change. What do we mean by constant rate of change? The rate of change is always the same. We'll take a look at that. A nonlinear function does not have this constant rate of change. So the graph is not a line. Let's say that one more time. Make sure I got it right. The graph of a linear function shows a constant rate of change. Nonlinear does not have a constant rate of change. So let's take a look at this example here. Okay, so first thing we want to make sure is that we have a common spacing between our input values. So all of these are increasing by 3. What are these? These are all decreasing by what? -8. Right? And because these are all the same, and if I was to do a ratio here of -8 over 3, they all have the same rate of change. And that's what we mean by a constant rate of change. Constant means the same. So these have a constant rate of change. So this is a linear function. Let's compare that to what's happening over in example B. Well, we do have an increase of 2 for all of our x values. That's good. But look what's happening here with our y values. 2 to 11, that's an increase of 9. And then 11 to 33, that's an increase of 22. 33 to 88, that's an increase of 55. So you can see 9 over 2, 22 over 2, 55 over 2, these are all different. I don't know what this is, but I know it's not a constant rate of change. And I also know it's not linear, which means it's non-linear. Okay, so again, we're looking for a constant, which means the same. Rate. Oops. Now remember, these are rates because we're comparing two numbers as a ratio. Constant rate of change. And I apologize for my horrible writing. They're all the same. Not the same. Okay? Let's take a look at something else. Well, this is easy. If we're looking at the graphs, is it a straight line? If it is a straight line, it's a linear function. If it's not a straight line, it's a nonlinear function. Hey, this is some kind of, when we get there, eventually you'll get there in a year or so with algebra. This is what we call a cubic function. This is obviously not a straight line, so this is a non-linear function. It says, explain, not a straight line. For B, we have this horizontal line going through y at -2. Y equals -2. This is a linear function. Because, why? Explain why. This graph is a straight line. Okay, that's super easy. Let's take a look at something more interesting here. Okay, now we're going to look at equations, and we want to know which represents a nonlinear function. So when we look at equations, if we want to know if it's linear, it can be written in the form y equals m times x plus b. Now, so we know this, we've been dealing with this most of the year, but let's kind of break down really what's happening here is that x is being multiplied by something. I'm going to call that a rate. And then some number is being added to that. And that couldn't be 0 as well, of course. A number is added after that multiplication. Okay, so let's take a look and see which of these things meet this requirement. So first of all, y equals 4.7. This is tricky because I can think of this as y equals 0 times x plus 4.7. Again, this is a simplified version of this, but x is being multiplied by a rate, and in this case the rate is 0. And 0 times x is just 0. So this is a linear function. For b, y equals pi times x. Well, we have this multiplication happening here, but what about this number being added at the end? Well, that number can be 0. So in this case, y equals pi times x. Pi is, we're multiplying, we're adding a 0 at the end. We don't see it, but it's there. So this is also a linear function. For c, y equals 4 divided by x. Well, remember we said that x is being multiplied by something. In this case, it's 4 being divided by x. Another way you might think of this problem, dividing is the same thing as multiplying by the reciprocal. I could think of this as this, or maybe something like that. But it's not 4 times x. This is 4 divided by x. This one is not linear, or nonlinear, to use the proper verbiage here. This is nonlinear. And what about this one? Well, we have to multiply it through to see, can we get in this form using the distributive property. 4 times x is 4x, and then 4 times 1 is 4. So this is definitely m times x plus b, so this is also linear. So the answer here is which represents a nonlinear function? The answer here is C. But the goal, remember, we want to see if we can put it in the slope-intercept form where x is being multiplied by some number, and then a number is added after that multiplication. But be aware that m and b can also be 0, as seen here in choices A and B. Okay, and let's see what we have left. I think that's it. The last example is a word problem. I'm going to save that for class. So we got the basics in here. I'll see you in class. Thanks a lot. Have a great rest of your day. Bye-bye.